Hello everyone, this is Reddy. Today I want to discuss about communication technologies and this mostly wireless communication technologies. Already I have completed wired communication technologies in a video. Now I am going to discuss about wireless communication technologies. Here these communication technologies generally they are used in two different layers, physical and data link layers of IoT communication and IoT architecture. Here many of the wireless communication technologies we know. In this wireless communication we have very short range and short range communication and medium range communications. In coming to short range, very short range, the first and foremost is infrared. Actually this technology is nowadays not present in mobiles. Here next coming to very short range communication, NFC, Bluetooth, ZigBee, etc. These comes under very short range communications. And short range communications, wireless USB, RFID, these comes under short range. And the medium range communication is Wi-Fi. First we will discuss about these: NFC, RFID, Bluetooth, ZigBee, CPRS, that means mobile internet, Wi-Fi and wireless USB. These are the main wireless communication technologies we are going to explain. And coming to wired communication, already I have explained this: Ethernet, wired USB, serial parallel interface, UART by USART, and I2C, the last one. Coming to NFC, we are all know about this NFC sharing. NFC means near field communication. Here it is a wireless technology. In this we use RFID standard. RFID means radio frequency identification. I'll discuss it later. Generally an RF antenna consists of two types of fields. One is near field and far field. Near field means electromagnetic radiations near to the antenna. We call it as near field. And far field means electromagnetic radiations far to the antenna. It is far field. And this NFC is very popular short range communication model. Generally it is operated at 13.56 MHz frequency, and the range of this NFC is means communication range is 10 centimeters to 20 centimeters, and the minimum 10 centimeters to maximum 20 centimeters. And this NFC has a data transfer rate which varies from 106 kbps to 848 kbps, simply doubling the date kbps: 106 to 12 kbps, 424 kbps and 848 kbps. Lowest is 106 kbps. It is the minimum data transfer rate, and 848 kbps is the highest data transfer rate. And this is a two-way communication. NFC sharing, generally this NFC sharing is done mainly in Android mobiles like Motorola, etc., and in Apple iPhones, etc. NFC sharing. Here this NFC sharing, the connection setup or the connection interval is less than 0.15 seconds. That means the NFC sharing will start once the connection setup in 0.15 seconds. In NFC we have three type of operation modes. First one is reader or writer, second one is peer-to-peer, and third one is card emulation. Coming to reader or writer mode, here the NFC device can read the tags. We all know NFC tags. Best example is fast tags. Simply a tag is nothing but a data that is visually integrated in a smart sticker or smart wall poster. Fast tags. And the second one is peer-to-peer devices. Here both are active devices. In the former reader or writer, one is active device and other one is passive device. In peer-to-peer mode, the two devices should be self-powered devices, means battery-oriented devices. Simply two mobile phones. Best examples, NFC sharing. Here the communication takes place between them for sharing the information, NFC sharing. And the third one is card emulation. Here the data is stored on the cards and it is read by NFC reader. Here the cards means smart cards. In this also there is a passive device and active device. The smart card is passive device and NFC reader is active device. It is majorly used in various applications, various payments, purchasings and various ticketings, etc. Here coming to the major application of this NFC. Generally this NFC is everywhere in airports and railway stations, not to buy a gate pass and getting the information from the smart posters and paying the parking fees, bus fare and taxi fare, and also mainly used in advanced vehicles, not to adjust the seat positions and opening doors. And these NFC are mainly implemented here in various software companies, office entrance and exit locations. NFC. And generally this NFC sharing somewhat better, and there are some certain drawbacks because in NFC we use RFID technology. Here RFID means we all know radio frequency identification. There are RFID tags. Generally RFID devices uses radio frequency waves not to communicate. These RFID tags, they are embedded with microchips and antennas. And why we use this RFID standards means here these RFID tags, they communicate with the reader with the help of antenna. And the operational frequency, there are three different frequency bands in this RFID. One is UHF, LF and HF. That means low frequency, high frequency and ultra high frequency. And the range of this RFID is maximum 3 meters. And it is the operational frequency on the data transfer rates varies from various devices. And RFID means one-way communication. And where this RFID standard is used is the patient ID management and logistics, warehouse management, mainly used in asset tracking, parking management. Mostly this standard is implemented in NFC. Simply buying, suppose if you go a supermarket and simply we can pay the bills by using our credit cards or debit cards without swiping. That is somewhat advantage as well as drawback is there, since these cards either credit card or debit card. Now they are having NFC technology. That means without physical contact with other device, you can pay bills. But there is a drawback in this. While using NFC technology, we should be aware with NFC readers, by which a thief can steal our data. By this NFC, from our NFC cards, you can pay the bills without touching our card. So now in Flipkarts and Amazons, there is anti-RFID purses or wallets coming, so that these signals cannot be transferred and our card will be safe. Actually, everyone, I am Ganpati Reddy. I want to continue my topic, communication technologies. Already have discussed NFC sharing and RFID technology there. Now I want to discuss about Bluetooth. We are all familiar with this Bluetooth. In every mobile, from basic mobiles to the smartphones, Bluetooth is there. Actually, it is introduced by Herald Bluetooth. And here, this Bluetooth, we call it as a classical Bluetooth. It is also a basic rate BR Bluetooth or EDR, enhanced data rate Bluetooth. It is a wireless technology standard, mainly for exchanging the data over short distances. Short distance means two Bluetooth devices will have a maximum of 100 meters, and this is a wireless alternative. This is the first technology after IR. IR means the two mobiles should be closely contact with each other, then only data will be transferred. That is the drawback. And the most widely used technology is Bluetooth, though it is short distance technology. It comes as alternative to RS-232 data cables. And this Bluetooth have the IEEE standard 802.15.1, and it is operated with ultra high frequency range radio waves. And coming to the operational frequency of the Bluetooth is 2.4 GHz to 2.484 GHz, and this Bluetooth is a bidirectional communication, and it has a maximum data transfer rate of 1 Mbps, and the setup connection between the Bluetooth devices is less than 3 milliseconds. And coming to the data, for our data while transferring with Bluetooth technology, it has a security of AES CMM 128, that means advanced encryption standard. That means 128 means 128-bit encryption. Coming to the network characteristics, this Bluetooth has self-configuring capability and self-healing and self-discovery. Just if you want Bluetooth in our mobile, it will search for various Bluetooth devices. That is self-discovery. And coming to the topologies of this Bluetooth network has two different topologies. One is Piconet and the next one is Scatternet. Piconet means it is a small network formed by a master and a slave, or a master and multiple slaves. That means the master means the device who initiates the connection, who is the sender is the master, and who pairs up is called slave. That means the receiver is called slave. Here for a single piconet there may be a maximum of 7 active slaves. That means 8 devices. Maximum number of devices that communicates in piconet is 8, along with the 7 slaves, 1 master. Here this is diagram for a piconet with a single master and single slave, and single master and multiple slaves. And coming here, the slaves can only transmit the data as requested by the master device. Otherwise they are only meant for receiving purpose. Totally in a parquet state for one piconet, if you consider, there are 255 slaves are there. And the second topology is scatternet. Scatternet is nothing but it's a combination of multiple piconets. Here a device can participate in multiple piconets. Coming to the data transfer rate, this Bluetooth have different classes. Based on the classes, the data transfer rate varies from the minimum data transfer rate is 720 kbps and a maximum of 24 mbps. Here we are all familiar with these classes. There are different type of classes: Bluetooth 2.0, 3.0 and 4.0. The advanced version is Bluetooth 4.0, which is called Bluetooth lower energy, or we also call it as Bluetooth smart reading. It has a maximum data transfer rate of 24 kbps. This is about Bluetooth technology. And the next wireless communication technology is ZigBee. It is mainly for low power devices. We also call ZigBee as ZigBee IP or ZigBee SC 2.0. It is mainly an IEEE 802.15.4 specification. Mainly it is used for high level communication protocols, and where the device have low powers and low data rate devices which has a close proximity like personal area networks and wireless ad hoc networks. We use this ZigBee technology. From security point of view, it is also comes with AES CMM 128 security standard, advanced encryption standard mechanism, and it is very less expensive than other wireless technologies, wireless personal area networks like Bluetooth and Wi-Fi. The range of the ZigBee is a minimum of 10 meters to 100 meters. That is the transmission distance, and it has a range of 200 meters line of sight. Line of sight is different from transmission distance. Line of sight means where the signal will appear. Transmission distance means until the last point of the signal. Line of sight is somewhat higher than the transmission distance. Not only for the ZigBee, for any communication technology there will be a line of sight which is just slightly higher than the maximum transmission distance. In ZigBee we use mesh network. That is the main reason why it is used in IoT devices, because not to share the data to distant devices, it uses mesh network of intermediate devices, and it has a data transmission rate of 250 kbps, which is the maximum, but it is operated at 2.4 gigahertz and also 915 megahertz frequency. Coming to the network characteristics, it is self-configuring, self-healing and self-discovery capability, same as like Bluetooth. And the applications of this ZigBee: wireless personal area networks, that's the first application, and IoT devices which are connecting by using the IPv6 and 6LoWPAN technology. Mainly it is for traffic management, home energy monitoring, and some industrial equipments and consumer equipments that requires a short range and low rate wireless data transfers. It is about ZigBee, widely used technology in IoT. And the next one is Wi-Fi. We are all very familiar with this. Without Wi-Fi, nowadays there is no mobile without this Wi-Fi feature. We also know about this Wi-Fi. Generally, Wi-Fi is wireless fidelity. It is abbreviation. And this Wi-Fi uses radio waves to provide the network connectivity. And how this Wi-Fi connection establishment is done. Compulsory, we should have a wireless adapter in order to create the hotspot. What is this hotspot? Just we are familiar that in our daily language we use the word hotspot. Simply connect the hotspot. Simply, a hotspot is an area, a personal network where the Wi-Fi access is available. It is called hotspot. We can create the hotspot from our mobile so that many of the devices for which this Wi-Fi is connected. Coming to the frequency of this Wi-Fi is, it is operated in two frequencies, 2.4 GHz and 5 GHz, and it comes with IEEE standard 802.11. The advantages of this Wi-Fi is it is compatible with every operating system, devices, printers. And why we are using Wi-Fi is it is easy to install and it is more flexible. It offers the mobility and routing, and the maximum coverage area of this Wi-Fi is up to 125 meters. Mainly the major application area is wireless internet, and the speed of this Wi-Fi, it may changes based on the type of the classes we are using. Whenever we buy a new mobile, we search for a new mobile, and in the technical specifications these Wi-Fi classes are available: 802.11 A, B, G and N. These are the four classes. Coming to the class 1, 802.11 A, it has a maximum data transfer speed of 54 Mbps and it is operated with in 5 GHz frequency. And the next one is 802.11 B. It has the maximum speed of 11 Mbps and operated at 2.4 GHz speed. And the third one, 802.11 G. It has a maximum speed of 54 Mbps and a frequency 2.4 GHz. And the advanced one is 802.11 N standard class. A maximum of 600 Mbps speed and operated at 5 GHz frequency. And coming to the security mechanisms, what we are used in Wi-Fi is WEP and WPA standards. Whenever we want to provide security to our Wi-Fi, simply we assign a password to that. That password comes under this WPA standard or WEP standard. WEP means wireless equivalent privacy. WP means wireless protocol access. And the last one about this wireless communications is nothing but mobile internet, which is GPRS or GSM cellular networks. Here the network may access the GPRS cellular network. We are all familiar with these words, GSM, GPRS. And basically in our cellular networks we have 2G, 3G, 4G, 5G, 7G, etc. 2G connection means we call it as edge connection. 3G means high speed access. 4G means LTE, long term evolution, and VoLTE, which is the latest in India. Now the research is going on for 5G and 7G. 5G is already successful in some countries, but the main drawback is with radiation. In Japan, they are already using 7G, many of the companies. And the last one is wireless USB. Simply, we also use this technology for our wireless USBs, means wireless mouse and wireless keyboards. It is simply a wireless extension of USB 2.0, and it is operated at the frequency ultra wideband frequency. We have two frequencies, 5.1 GHz and 10.6 GHz, and this wireless USB is a short range personal area network. It is operated based on the distance. For 3 meters the maximum speed is 480 Mbps, and for 10 meters the maximum speed is 110 Mbps. These are all about wireless communication technologies. Thank you very much.